All right, number 2. What forces hold covalently bonded atoms together? Electrostatic attraction or forces. Then you have what, number 3. What number of valence electrons do most atoms, other than the first few elements of the transition metals and the inner transition metals, seek to have after forming bonds? 8. Then which one?
4.
Number 4. Which 7 elements occur naturally as diatomic covalent molecules?
Hydrogen, nitrogen, oxygen, fluorine, chlorine, boron.
All right, very good. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Number 6. Draw the Lewis structures for the following elements. PO3, 3 negative. There's the extra 3 electrons. So there's phosphite. Questions on that?
Can I put like oxygen on like, does it have to be on one side like this?
It doesn't have to be.
It can be like all on the right side.
It could. I usually put it where the extra electrons came in. COBr2. Alright, so here you have 4 elements. Which one is going to be central? Your carbon. And so basically what's going to happen, I believe it's going to go like
Carbon only has 6 now.
carbon only has 6. Yep.
So
Good
you
double
take
bond.
oxygen away and then put 4.
Oops. Double bond. Alright, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, there we go. Sorry. Do you have a double bond here?
You can do.
They have 8. Cn negative. And let's go ahead and bring in the other electron here. Let's bring it in here. So we have 6 there and 4 there. C needs 4 more. There's that one. And SiHCl3. Go ahead.
Previous one,
Uh-huh.
is that a triple bond?
Yes.
So then wouldn't carbon have too much?
That is 6, 7, 8.
Oh wait.
6, 7, 8.
No.
Yeah. And that extra electron is right there. SiCO3H. Si has how many?
4.
No.
It's SiHCO3.
Is that correct?
Yeah.
Alright, so Si, we'll move those around. Go here, here, and here. CO goes here. CO goes here. CO goes here. And H goes here. Any questions there? We'll be doing some more practice here in a little bit. What's the next question?
9.
Number 9, predict the units of ionic compounds that form the following atoms based on the number of valence electrons. MgBr. It should be MgBr2. Al and Cl should be AlCl3. Rb and I, that should be RBI. Sr and F, should be SrF2. And we'll discuss this a little bit if you didn't get these. And Ca and O, calcium oxide. I was hoping to get to that before homework of the day, but I didn't. All right, questions? All right, pass those forward, please. See you right there? Is this down? I know these are messed up, so I keep them down. You can move over here if you want, or up. All right, covalent bonding. Again, we're talking about covalent bonding, sharing electrons. I had to go back and restart. Let me see where I'm at. Here. Polarity. She put 2s with all these. All right, so if we have an element that has more than one carbon in it, usually that element, those carbons are bonded together. So take for instance, if I have C2H2, a C2H2, let me change that for C2H4. We would usually bond that carbon together. So we have 2 C's. And we have 4 H's. So when we see this, it's always symmetric. We're talking a little bit about organic chemistry here. And so when we see this, they're always symmetrical. So we're gonna put the two C's together. We'll start out with a double bond, and we got 4 H's. So if I use 2, let me do this differently so you can see it better. So we have 2 from each carbon, and then we have 2 left. And the H's will come in right there. So it still gives me 1, 2, 3, 4, 5, 6, 7, 8, and hydrogen both has 1. So a lot of times when you see the carbon, if you have a multiple of carbons, they will be bonded together. Let's see if we can find another one here. Let's go back and do the C2H2. All right, again, carbon, there's 2 of them. And there's 2 H's. So carbon needs how many more? 4. H needs how many more?
2 or 1.
1. So each H is going to get 1 from each carbon. So that means carbon needs to have how many more? If it gets 1 from the 1 from the H,
5.
it needs how many more?
3.
3. So where's it going to get those 3? It's going to get it from each other. So we will put the 2 C's together. And have them sharing the 3 carbons from each other. And therefore the hydrogen will get the other one. And there's my covalent bonding. So you just have to play around with the numbers, find out how much everything needs, and then get them together. Let's look at CS2. Again, we're looking at carbon and 2 sulfur. So the carbon has 4, each sulfur has 6. Each sulfur needs how many more? Each sulfur needs how many more? 2. The carbon needs 4. So the sulfur is going to get the 2 from where? From carbon. And the carbon is going to get the 4 from where? The 2 sulfur, correct? So I split that in half, so we're going to get 2 from each sulfur. And each sulfur is going to get 2 from the carbon. So therefore, what kind of bond would we have? A double bond. So if I put the carbon, this 2, and then the sulfur with this 6, and there is my compound. So it's going to take a little bit of practice, but again, that is the thought process. Well, how many electrons does it need more? Let's see if I can find another one here. Let's look at this polyatomic ion, OH negative. Oxygen has how many?
6.
Hydrogen has how many?
1.
And we get 1 extra electron from somewhere. So we put the extra electron in. So there's only one place for the hydrogen to go. The hydrogen will go right there at the bottom. And we always put it in brackets with a minus sign. Let's look at another one.
So do you always put the extra electrons like a open circle?
What's that?
Do you normally put like the extra electron as an open circle?
You don't have to. I do that so you can see where that extra electron came from,
Okay.
where that electron came from. But you can just use dots or X's, whatever you want to do there. Let's look at another one. Let's see. Polyatomic ion. That's not a good example. ClO3 negative, alright, which is chlorate. Which one's my central atom? Cl. How many electrons does it have? 7. You get 3 oxygen. Alright, so I get 1 extra electron. Where would you put it?
On the CL.
Okay. And so therefore, the oxygen is going to get 2 electrons from where? From the chlorine. So we can put a Cl here. Put this 6 electrons, a Cl here.
Is that,
Put this 6
You
electrons.
mean oxygen?
yeah.
I mean, what am I doing with the Cl?